Right. Hello, everybody. So today I am going to talk about a very classic probability problem, which is the birthday problem. The problem goes as follows. What is the minimum number of people at a party in order to have over 50% probability of finding two people with the same birthday? And I should add here it could be more, at least. So let's start thinking about some easier cases, right? So let's say if you have two people, what is the probability that they will have a collision in their birthday? Well, the first person, it could be any of the 365 days of the year. Then for the second person to have a collision with the first person, then he will have only one day to choose from, which is basically whatever day that the first person have its birthday, the second would have to match. Well, what about for three people? This gets a little tricky, right? So suppose you have person A, B, and C. You can have A and B with the same birthday, B and C with the same birthday, or A and C with the same birthday, or even A, B, C all having the same birthday. And you have to sort of add up all this probability. And you can see that as you get to the cases of 4 and 5 and even more people, this gets really complicated. So a better way instead to think about this problem is to think about what is the probability that nobody have the same birthday. So no same birthday. Why is this a good way? Because we can do 1 minus that to get the probability that at least someone have the same birthday. So let's call this P of maybe N, P of no, so no same birthday. So for two person, in order to have no same birthday, the probability is going to be that the first person still have arbitrary days he can choose from, and the second person basically would have to choose a different day that doesn't collide with the birthday of the first person. And so you can see that this just boils down to 364 over 365, and which is equal to the 1 minus this earlier number. And for three people, the probability that nobody have the same birthday, actually it's quite simple. Basically the second person again can collide with the first person, and the third person cannot collide with the first two person. What about for four people? It's actually going to be the very similar pattern. It's going to repeat the same parts, right? So this three number multiply together, and then you multiply by 362 over 365. Because for the fourth person, so this is the fourth person, he or she can only choose from 362 days because 3 days are already taken previously. If you want to find out for X number of people with the no birthday, then this is just going to be this same pattern, but repeated for X times to get the original question where some pair of people in the group with the same birthday we'll go back to do the 1 minus p of no same birthday, which is again is this formula right here. It's quite hard actually to do this manually, but it's actually very easy to do this in Excel. And I'm going to show you guys a way to do this in Excel. So here we have a Google Sheets. So first we have X being the number of people at the party. So I'm going to iterate, basically keep trying until I get to the 50%. So let's go up to some arbitrarily higher number. We can just drag down in Excel. And the next number we want to calculate is the probability that there's no same birthday. So for 2 people, it's going to be 364 divided by 365, right? So you remember that from this case here, where the 364, and then the next one you just do 363 over 365, and then the next one it will be 362 over 365. So how do we put that pattern into Excel? So the way I'm going to do it is I am going to add a column which is called I guess I'll call it the numerator. And for the case of x equal to 2, the numerator is 364. And for the case of 3 people, the numerator is 363, and so forth. So I just drag it up all the way. And okay, I forgot an equal sign here. So this is the starting condition. There's a 99.7% that 2 people would have no same birthday. Then the way we want to do it is, for 3 people is we use the number from 2 people and then multiply by this numerator, because the third person have 363 choices left to choose from, divided by 365 days in a year. And then we can again drag this down all the way. And then finally, we are going to do the probability with some pair of people with the same birthday, which is just 1 minus that. So I'm going to do 1 minus this probability at column C. Nice. So Google Sheet have done the automatic code completion. So if you look down all the way, probability of same birthday is really small, close to 0. And as the number of people goes up, it starts increasing. At 10 people, it reaches 11%. Keep going down. And then you see that at 23 people, this is the point where the probability reach 50.7 to be precise. So that's all. Here is how we do it in Excel. Thank you.